Okay, so I think it's really important that you say if you're stuck, be as honest as possible, right?
Yeah.
If you haven't understood the question, that's okay. It may be that the interviewer just hasn't asked it in a very clear way. It's okay. So ask for clarifications. And if you're stuck, and you will get stuck, that's kind of the idea. It's good to ask. Say, okay, I'm stuck. So it's a kind of a slight juggling act, right? Because you want to. You don't want to sit there being stuck and just stressing about it. It's a scary process unnecessarily when actually your interviewer could give you a small hint. However, at some point, the questions are designed in a way that you almost certainly will get stuck at some point, and it's how you get unstuck that we're interested in. So you should ask for help, but you should also be tenacious, right? Don't give up. If you don't see how to do something, that's okay. The purposes of the interview is to try on your feet to kind of work it out. And it's okay to do that with the help of the interviewer as well. Right? So in some sense, another reason why the interview is a useful complement to the written application and the step paper is that it relatively closely approximates a Cambridge supervision. Right, which is the kind of standard 2-on-1 teaching process where we'll sit down, we'll talk intensely about a particular area of mathematics. And it also gives us a little bit of an insight into how someone would, how they would do in the supervision environment. Do they know how to make use of that?
Hello everyone, welcome to Cambridge from the Inside. We're here with a returning guest. Would you like to introduce yourself?
Hi, I'm Reid-Edwards. I'm a Director of Studies in Mathematics and a Fellow at Trinity Hall.
Nice. And we're here today to talk about interviews advice for maths, any maths applicants who have an interview coming up. We're going to go through everything that you need to know and how to prepare for your interview. So firstly, why do we have interviews in general, and why specifically for maths? How do we use them?
Okay, so probably the best way of understanding why we have them is to try and put yourself in my position, right? So we tend to take about 6 maths undergraduates each year, and we'd probably interview about 60 people.
Okay.
Right, so we've got 60 or so people applying, and before the interviews or before any other data, the only information we have is the application. And on that application, everyone looks great, right? Okay. They're all fantastic mathematicians. They're all predicted really good grades. They've got great references. These are really promising young individuals. So they're performing really well at the level they're working at now. And the question that someone in my position has to ask is, how do I take that very limited information and extrapolate to work out, of those, say, 60 people, which 6 who eventually arrive here are going to have the best shot at doing really well and excelling at that next level? So the reason we have interviews and also the step exams for those who are given offers is really to give those of us who have to make those difficult decisions amongst this wonderful pool of applicants more information so we can try and make a better quality decision. So it's really about getting information. And if you're thinking of taking on a student, a natural thing to do is to talk to them about the subject, try and get a feel for how they think about mathematics. And that's really the main role of the interview, just to get a bit more information so we can make a better quality decision.
Nice. And we've got this question a bit later on, but now that we're talking about it, what does a maths interview involve? Are we asking questions about why they applied for the course or applied to the college, or is it purely based on solving or answering questions about maths and maths problems?
Okay, so it will almost entirely be about maths problems. That's one of the first things we'll say at the beginning of the interview, that it's quite a short process. Time goes very quickly and want to make the best use of that time possible. So we'll tend to assume that your motivations for wanting to study mathematics are honourable, and we'll focus most of the time on just trying to probe your ability with maths and kind of stretch you a little bit to see how you adapt to new situations. Now, obviously, there'll be a tiny bit of small talk at the beginning, but that's going to be more about just trying to settle you into the interview. Before we started this podcast, we had a bit of small talk, and I think that's partly putting my nerves at rest to settle me into the podcast. So it's something like that. It doesn't really form part of the assessment. So, I would be, as an interviewer and a mathematician here, I am interested to know why you'd want to do mathematics, why you'd want to apply to Trinity Hall, but that's not going to be part of the assessment. Okay, so it's really the maths part that matters.
Nice, yeah. And bit more on the logistical side, just for viewers to know how many interviews should they expect if they're invited for a maths interview.
Okay, so different colleges might do slightly different things. What we do at Trinity Hall is pretty usual for what happens in Cambridge, and there aren't any massive disparities. So what we would do here is everyone who's invited for an interview will be given 2 25 minutes or so interviews with 2 separate sets of people. And in that time, we will just sit down as we are now, and we'd ask you maths questions.
Yeah. And what's the format of the interview? Are the interviews in person or online? And I assume that would differ between the colleges as well.
Yes, that does differ quite a lot between the colleges. And to make it even more complicated, it can differ from year to year within the same college. Yeah. So, for example, last year, all of our interviews were online for home and overseas students alike. Yeah. This year, we're trying out having home students in person and overseas students online. Now, there can be some variation within that, but that will be the general pattern. But what we're looking to get out of the interview, kind of that extra information to make a quality decision, doesn't change. And we have a lot of experience doing online interviews and in-person interviews. And in-person interviews were the norm before the COVID pandemic.
Nice. And just like reassure anyone who's watching, if someone who's applied to Trinity Hall has a online interview for maths and someone who has an in-person and someone else has an in-person interview for maths, they're going to be receiving the same interview. It's just the format that's different.
Yeah, that's right. So there might be slight differences, like because of the technology, we might have to do things slightly differently. So, for example, if you're being interviewed in person, there'll be paper and pens on the table, and we'll be able to kind of see what you're doing as you write. If you're interviewing online, we won't necessarily be able to see everything you write. We'll be able to see whatever you write in a shared whiteboard, but you may want to do some small working on a scrap piece of paper. And to balance that out, we may ask you to just hold up some working. But the principles and the difficulty and the style of questions will not be any different.
Nice. And so during the interview, you were saying before that is most of, if not all of the interview, will be answering questions on maths problems. In terms of how the difficulty of the maths, is this going to be like maths A level or further maths A level, or is it going to be stuff that's beyond that?
It's a bit of both. Okay. So one of the purposes of the interview will be to just check that you're sort of on top of the things that you should be on top of. So things that you've covered in the course so far, and just checking your proficiency with those things. But then you would find that the interview questions will then sort of develop into areas that become more challenging and also, importantly, less familiar. Yeah. Because one of the difficult jobs an interviewer has is to try and strip away all of the training you've received and see how you deal with an entirely novel maths problem. The reason for that is, it's probably manifold, but two particular reasons are different applicants will come from different schools who will have been able to provide different levels of support for the interview. And we don't want the school that you've been to overly influence your chances.
Yeah.
A second reason is that doing maths at university is very different from doing maths at school. right? There will be contact hours, you'll have supervisions, you'll have lectures, but a lot of the really important learning, the forming of the neural networks in your brain that make you a better mathematician, will happen kind of on your own in the library. So one of the things we'll be interested in seeing is how you deal with and adapt to problems you've not seen before. So in many cases, we may ask questions that are not necessarily harder than what you've seen in maths or further maths, but perhaps take things in a very different direction. So it takes you into areas you perhaps haven't thought about before. And that acts as a great leveler, but also enables us to see how you cope and deal with new situations.
Do you have an example that you could share with us that that's not going to be used in interviews?
What? Okay. Do I have an example that I wouldn't want to use in interviews? Yes. Okay, I have to remember not to use this one now.
Okay, yeah. We'll be on YouTube.
Okay. So for example, I think that there's a lovely interplay in mathematics between geometry and algebra. Okay. So you can describe a circle in a Cartesian plane as x squared plus y squared equals, say, 1. So that would be a unit circle. Right. And this idea generalizes. So if you want to describe the surface of the two-dimensional surface of a sphere, the two-dimensional surface of a ball in 3 dimensions, you could describe it by x squared plus y squared plus z squared equals 1. Okay, so there's kind of this duality between this geometric idea and an algebraic description. And if I asked you to find all the points that lie in the intersection of 2 circles, that's kind of easy to imagine. You can imagine they touch at a point, or they overlap in 2 points, or they don't touch at all. And you can also see that from the algebraic side by solving 2 simultaneous algebraic equations. Okay, you could do that for spheres as well. You could say, okay, what happens when we have the surface of 2 spheres? They'll either just touch at a point or intersect in a circle, or they'll completely overlap. Okay? And again, you can see that from solving 2 algebraic simultaneous equations. But usually it's a bit easier to picture what's going on geometrically for the circle or the sphere case. But then I said, okay, maybe we live in 10 dimensions. I like string theory, so let's say we live in 10 dimensions. So let's think of a 10-dimensional analog of a sphere. Now I can't picture that, right? Our brains haven't evolved to do that. But the algebra becomes not really much harder. Yeah. And so I could then talk about the intersection of 10-dimensional spheres in 10 dimensions, or I guess there'd be 9-dimensional surfaces in a 10-dimensional space. Geometrically, the picture, got no idea, but the algebra is easy. It gets no harder than the circles case. So a question that I've used in the past, I will not be using this year, or probably ever again now, because the cat's out of the bag, is to talk people through, kind of give them the equation of a circle. Kind of, what is this? Tell me, what do you have you met this before? What do you think it is? And then a sphere, which most people probably haven't met, right? And then we talk through and we kind of think about why that algebraic expression describes the geometric object. And then I might say, okay, can you find the locus of intersection? First, just maybe by thinking about it, but then doing a calculation. And then we ask to generalize. And so it's completely, I don't think anyone at A-level or equivalent overseas will study 10-dimensional geometry in their studies. But actually the mathematics is no more difficult than doing just circles intersecting. So it's not something that's necessarily harder, but it's sort of orthogonal to what you normally do. Yeah. But you have to really understand what's going on and kind of think on your feet a little bit. Yeah. And you start to spot the pattern. So that's a sort of question that could in the past, but not this year, have been be quite useful in kind of picking out students who might actually be able to kind of really take things to the next level while thinking on their feet.
Nice, yeah, and I think it's definitely possible. It's easy to see how it's not like like a concept that's completely beyond what they know. I can see how it's like linked from the A-level content and then the more lateral rather than more advanced.
That's right, and it's relatively short, right? So one of the challenges an interviewer has is to try and get as much complementary data as possible in that short amount of time. So what we would like to do really is just ask a number of different questions on very different topics, because there are many ways of being a good mathematician.
Yeah.
Right. And so it may be that someone doesn't do so well in one area, but does really well in another area. And that's okay. No mathematician is amazing across the board at absolutely everything. We each have our strengths and our favourites and the bits we're more interested in.
Nice. And that nicely leads us on to our next question on what should a student do if either they get stuck or they receive a question that they just don't know what the answer is.
Okay, so I think it's really important that you say if you're stuck, be as honest as possible, right? Yeah. If you haven't understood the question, that's okay. It may be that the interviewer just hasn't asked it in a very clear way. It's okay. So ask for clarifications. And if you're stuck, and you will get stuck, that's kind of the idea. It's good to ask. Say, okay, I'm stuck. So it's a kind of a slight juggling act, right? Because you want to you don't want to sit there being stuck and just stressing about it. It's it's a scary process. Unnecessarily, when actually your interviewer could give you a small hint. However, at some point the questions are designed in a way that you almost certainly will get stuck at some point, and it's how you get unstuck that we're interested in. So you should ask for help, but you should also be tenacious, right? Don't give up. If you don't see how to do something, that's okay. The purposes of the interview is to try on your feet to kind of work it out, and it's okay to do that with the help of the interviewer as well. Right, so in some sense, another reason why the interview is a useful complement to the written application and the step paper is that it relatively closely approximates a Cambridge supervision, right, which is the kind of standard 2-on-1 teaching process where we'll sit down, we'll talk intensely about a particular area of mathematics. And it also gives us a little bit of an insight into how someone would how they would do in the supervision environment. Do they know how to make use of that? Yeah, so definitely ask if you're stuck if you haven't asked the question.
Nice. So, and how often would you say when you've done interviews in the past that you've seen someone who's momentarily stuck but have been able to work their ways through a question?
Most of the time. Right. So that's kind of the standard thing. Right? So if you ask someone a question and they rattle it off very quickly, perhaps they've seen how to do it before or something like that. That's useful, but it's not really useful for the interviewer. So we would tend to ask questions until someone started to get stuck, and then sort of help them get unstuck and see how they puzzle through. And it's this. I mean, it's the interview process is horrific in many ways, both for the interviewee and the interviewer, because everyone's kind of quite tense and nervous, and you really feel for the person who's kind of doing their best but is maybe stuck. But there is this beautiful moment sometimes when people are struggling with something, then suddenly the penny drops. They say, that's how you do it. And there will be a way to do it, or a number of ways to do it. So that's quite normal that someone will get stuck and will stew on something for a bit, but then it'll fall into place.
Nice. And what if the interviewee has received a question or has presented with a problem that they haven't gone through the content in school, or they might think this is something that they're about to go through in school, but they haven't yet. And I guess what I'm trying to say is there's a fine line between how do they know if they're presented with something that the interviewer knows that they haven't seen before, or the interviewer doesn't know that it's something that they should have seen or will see soon. Do you see what I mean?
I do, yeah. So very often the interviewer will ask, have you covered X at school yet? The interviewer may forget, right? So I think if you're presented with something that seems to assume you know something that you've not covered or you're just about to cover, say in the interview, that's fine. It's not going to be a black mark against you, right? And that's okay. And it may be that the interviewer will adapt the question slightly, or they may move on to a different topic. So if the question relies on specific techniques that you have or haven't been taught, okay, maybe a better question would be more revealing and a better use of the short amount of time we have together. But it could be that the interview says, okay, you've not seen this before. Let's go through it anyway. And then what would have been a problem that the interviewer that would have been something that was sort of standard bookwork, something that had been seen before, now becomes that more challenging part.
Yeah.
And there have been cases in the past where a candidate hasn't seen something before, and we were able in the interview quite quickly to teach them a new technique, which they could then apply. And then that's something new. It's like that was the sort of unseen, the novel element.
Yeah.
But always say if you're worried.
Nice. I guess to communicate, because it's quite easy and quick to communicate that with the interviewer, and then you can see whether the interviewer is expecting you to have not known what they presented or to have known what you presented.
Absolutely. And I think communication in the interview is really important. So most interviewers, I think, will say at the very beginning of the interview some words along the lines of, it would be really helpful if you could explain your thinking as you're working through things, which is a kind of funny thing to do, right? When you're working through a maths problem, you normally don't talk to yourself, oh, now I'm going to do this and then I'm going to do this. Yeah. But it is very helpful because it sometimes it sort of uncovers and makes much clearer to the interviewer how you're approaching the problem. And perhaps if you're going down a dead end, then the interviewer can say, let's try something different. Why, or have you thought of doing this to try and steer you back on the path? Yeah.
I guess if you don't communicate or speak out loud your thought process, then if you're stuck or unsure about something, the interviewer has no idea what you're finding difficult.
Exactly. Yeah.
Nice.
And as an interviewer, it can often be difficult to tell the difference between someone who is completely stuck and someone who's just sitting thinking.
Okay.
So it's that communication is useful.
Nice.
Similarly, if you're not stuck and you're just thinking something through, like you're doing a bit of mental arithmetic or something, you can always just say, hang on, I just need a minute because I'm thinking about something, and the interviewer will understand.
Nice. So the next question I had was, so for applicants they'll be hearing back very soon, if not already, whether they've been invited to an interview, how should they prepare for their maths interview? Okay,
so I think one thing that's quite important is making sure that you're on top of what you should know. Right, so if you've covered certain topics in your A-levels or equivalent so far, just having a look back over those and making sure you have understood them and there aren't any gaps that you haven't filled. You don't have to read ahead. That's okay. As we've spoken about before, it's perfectly okay to let the interviewer know that you just haven't covered that yet. But there would be an expectation that you do know how to use the things that, for example, the chain rule or something that you should have covered by that stage. The other thing that can be very useful to do is while you're doing that is try and think a little bit more deeply about that material that you've been exposed to. So, for example, trying to understand some of the reasons behind the techniques that you've learned and why they work. Because a lot of the questions, as I said, they won't necessarily be technically more challenging, but they might require a deeper understanding of the material. So examples might be if you've learned proof by induction. Right, think about what sort of statements induction is good for proving. Or if you've done some mechanics, you will have learnt SUVAT, kind of this recipe that takes a problem and generates answers. But actually what we'd like to see is some understanding of where that comes from. Not applying the knowledge as a recipe, but understanding kind of the details of where that really comes from and how that should be used and what the limitations to those things are. So just as you're looking over your material, just ask yourself kind of, how deeply do I understand this? Are there any gaps in my knowledge? Are there any recipes that I've just adopted as recipes and I should perhaps think a little bit more about? And the other thing you can do is read around a bit, right? Start to challenge yourself and maybe look at some step papers and things like this.
Nice. And so, so from my memory of doing like maths and further maths, like the textbooks, um, there was like maybe like a chapter would explain like a theory or an approach, but might not explain, might not answer a lot of why questions. So would a good advice, instead of like reading ahead, as you were saying before, might not be very that useful. Would going through like a further maths textbook or a maths A level textbook, challenging yourself on how do we know these things, would that be a good way of deepening your knowledge, like your maths and further maths A level knowledge?
Yeah, I think it might be. It kind of as part of the process of going over the material and make
Yeah.
sure you really understand things. Start to actually reflect and think about how deeply do I understand these things, and am I just regurgitating a recipe, or do I see how different ideas perhaps link together? Because obviously when we teach mathematics at schools and universities, we teach this topic, then this topic. There's got to be some way of organising the material. But in some sense, it's an organic subject, and the barriers we put up are in somewhat artificial. So seeing how different areas of mathematics link together, as I was saying, between algebra and geometry, that's also a way of deepening your understanding as well. And also thinking about the limits of the techniques you've learned. What sort of problems of that kind can you solve with these techniques, and what sort of things would I know straight away that I would need new techniques to solve? That can be useful.
So even like if a textbook doesn't talk about the limits of an approach, kind of asking yourself what I've learned, what is it useful for, and what things are kind of like what that they haven't covered through, and how to use for other things. Does that make sense?
Exactly. Or things like, this isn't a good example because I'm just thinking it off my head, but there's this kind of standard formula for solving a quadratic equation.
Yeah.
Right. So a natural question you can ask is, can I derive that?
Yeah.
Can I actually, if I hadn't been taught that, knowing what the answer is, how would I go from the problem to this formula? That would be a kind of a natural thing to think about.
Nice. Yeah. The one thing that keeps coming to mind is like, it's very easy to differentiate something, but not necessarily be able to do it from first principles, or at least I would have found that difficult. And I guess if you can't, I guess I would never be able to explain what I was actually doing, but I knew how to do it, I guess, which reveals how much do I actually know what I'm doing.
Yeah, and also as well as that, just being on top of the techniques, because as I sort of stressed, the interview it's not very long, 25-minute or so slots, and you want to maximize the amount of time you spend thinking about the kind of difficult, novel part of the problem. You don't want to waste too much time thinking about, I can't remember how the chain rule works. So just being kind of on top of the stuff that you should know, so that you can get that bit of it out of the way efficiently, so that you've got more time and energy to focus on the more challenging part.
Nice. So on more of the conversational part of the interview, how can students prepare for that side? Because as you were saying before, they might not be used to talking out loud their math solutions.
You mean, so by conversational part, you mean kind of as they're working through a problem, kind of explaining what they're doing. Actually, this is a good practice, right? Because very often you can be given a problem and you just start kind of trying to go through it without really knowing, without any plan, without knowing what you're actually trying to do. And so just slowing down a bit and actually talking through to yourself, what am I doing here? What's my strategy? That's just quite a useful thing to do anyway. So one thing you could do is take some textbook problems and set them for yourself, and just talk through to yourself out loud if you want, kind of what your plan is. Because I think if you do that it will be very clear to yourself if you have no plan, if you have no clue, you're just kind of throwing everything at the problem. And that might give you pause and make you just sit back and say, okay, I need a strategy for solving this. Where am I actually going?
It's practice talking through your process.
Exactly. And regardless of Cambridge interviews, that can actually be quite a useful thing to do.
I guess it would be useful if you know another person who's applying for maths, that would be great because you could both go over problems and talk to each other. But even if it was just anyone just trying to explain to them your approach, and having someone listen might be of help for that conversational side.
Yes, and it starts to develop quite an important skill about just having a conversation about mathematics, which can be very, very helpful. It has that clarifying role of you think you understand something until you try and explain it to someone else, and you realize actually this is a much harder sell when I have to actually explain it to someone. So that's very helpful. But also when someone's explaining something to you, interrogating that explanation, not just accepting it, but thinking, well, actually, have they really covered all the possibilities? Have they filled in all the gaps?
Yeah.
So that skill of discussing mathematics between two people or more is very useful.
Nice. And this is a bit of a tangential question, but how common is that at university, whether it's in supervisions or life as a mathematician, that you will be with other people talking about maths rather than always like writing down math solutions? Like, how much of it is a discursive topic?
I think probably you would spend less time talking than writing, but the talking time is really important, and maybe that's got a higher productivity to it per hour spent than just the writing. So we in the supervisions, the standard supervision, a student wouldn't write very much in it. The supervisor would write some things, but it'd be more sort of discursive because it frees up the student not having to write down, take notes, or do the calculations there, and then frees up time for them to actually think about what's going on. So that discursive skill is important in supervisions, but also we encourage all of our students to talk to other students about mathematics and to explain things to each other. It's obviously useful if you're stuck and someone explains a problem to you, or a technique, or how to see your way through, but it's actually a really useful experience for the person doing the explaining, because it helps kind of organize their thoughts. And as I said before, it's really easy to pull the wool over your own eyes. If you have to explain something to someone, it's much harder to do that and keep a straight face.
Nice. I have fond memories of me and my friends who are doing further maths, of like spending a lot of time around whiteboards and taking turns explaining our workings out on the whiteboards, and it being a much more social activity than what it was like before that.
And it can be fun, right? To just brainstorm a problem.
Exactly. Which is, I guess, the reason why people apply to do maths. And lastly, can you explain how, because there's also the STEP admissions exam, how do we use the interviews alongside STEP and the kind of timeline of both of those things as well?
Right. So the basic principle is, as I said at the very beginning, it's all about getting as much data to make the best quality decision we possibly can. So the way it would work is, if you apply, you may be called for an interview or 2 interviews, and we would probably aim to make offers to probably a quarter to a sixth of people who we interview. So the interview is doing that first cut. It's just trying to differentiate that pack of applications that on paper look very similar. And we don't always get that right, but we do the best job we can. And then if we make an offer to you, it won't be unconditional. It'll be conditional on A-level or equivalent results, which most people achieve, and also STEP, which is these 2 exam papers, confusingly called Step 2 and Step 3. There is no Step 1 anymore. And we would make a entry conditional on doing well in those. And people often focus on the interview, and that's the thing that after application, that's the first kind of test you have. But actually STEP is something that should be taken very seriously as well, because a lot of people we make offers to, the majority of people we make offers to, don't make it past that last hurdle. Okay, but you can take things one after the other. You can kind of, they happen sequentially. And the hope will be that at the end of it, we've we've probably used that information well and made the best decision
Mm.
we can. I mean, it's certainly the case that anyone who receives an offer is definitely good enough.
Yeah.
But it's also the case there are some people who don't get offers who are good. So it's important that if you apply and you don't get in, you don't kind of give up on your dreams of doing mathematics or theoretical physics. You stick with it because we don't always get it right. And also there are more fantastic people out there than we have places, unfortunately.
Nice. And just lastly, just one more question about preparing for the maths interviews. Does like the step pass papers? I mean, I know the step pass papers definitely help for preparing for step, but is there any correlation between the step pass papers and what you might be asked in an interview or preparing for the interview?
So I think there are two questions. Firstly, how closely are the questions in step and interviews? And the second is looking at step papers useful for preparing for interviews?
Yeah.
So I think that the style of questions in the interviews tends to be quite different for a number of reasons.
Yeah.
Firstly, we want to get as much useful but complementary data as we possibly can. Yeah. And so one of the things in the interview, as I mentioned, was that we'll try and ask you lots of questions on different topics. So maybe cover 3, maybe 4 topics. And so what we wouldn't want to do is set a step style question where you spend the whole 20 minutes working through that one thing that's very calculationally heavy. So the style of the questions can be quite different. And that's also useful because then we get to see how you do in the supervision style interviews, and also how you do in the step paper, which if we make an offer, we will see how you get on with that later on anyway.
Yeah.
So I think the actual style of questions are quite different.
Yeah.
The ones in interview, particularly bearing in mind that we'll be asking some of these questions to candidates who are online. And so we can't see them writing lots and lots of algebra down. Yeah. They tend to be more focused on thinking through a problem. Yeah. Right. Whereas step, there's obviously a lot of furious writing. There's lots of thinking as well, but there's a bit of furious writing to be done as well. However, preparing for the interviews, I think probably the best thing you can do is to just immerse yourself in as much high quality mathematics as you can and get yourself used to thinking about novel mathematical problems that are kind of just slightly outside your comfort zone. Yeah. And step definitely ticks that box. So I think you would not be wasting your time looking at step questions. And also bear in mind that if you get an offer, the next thing is step. Yeah. Right. So that's engaging with that sooner rather than later can always be beneficial.
Yeah. Nice. Well, thanks, Ron. It's a really interesting podcast. Unless was there anything else you had to say about maths interviews, or?
I don't think so, except to say that your interviewers aren't evil and terrible, and hopefully we'll make it as it's obviously stressful. There's no getting around that because there's for the person being involved, there's a lot at stake, right?
Yeah,
for them.
yeah.
Or they certainly will feel so.
Yeah.
So it's we will do our best to make you relaxed and as comfortable as possible.
Yeah. Wow.
And I guess the last thing to say is that it is very difficult to know how your interview has gone.
Okay.
Right. Because remember I said that we'll ask you questions until you reach something that you can't really do and see how you puzzle through that. So if you kind of rattle through a question very easily because you've seen that technique before, that's possibly not, for an interviewer, not the most interesting part of the interview. So however you feel it's gone, don't worry about it afterwards, right?
Yeah.
And we do recognise that we're only getting a snapshot of your ability over two short 25-minute sections. So don't take it as a personal judgment in any way.
I guess it's also important to say it's not an interrogation. The interviewers want the interviews to do well.
Exactly. Yeah. No, exactly.
Nice. Thank you everyone for a really interesting podcast on interviews advice for maths. we're hoping to do more podcasts on interviews, advice for the remaining subjects that we haven't done. We have several playlists on our YouTube channel, playlists of different topics of podcasts that we've done, and one of them is a dedicated playlist to interviews advice. So I'll definitely check that out and see if we've done the subjects that you're applying for. And we've done a lot of interviews advice podcasts, going over general advice, or Marcus goes through his advice for arts and humanities subjects and science subjects as well. So definitely check out the content that we have so far. If you have any interview coming up, good luck, and we'll see you guys next time. Nice. Oh, how was that?
Oh, don't know. Hopefully there's something useful for you.
It is. I was really good.
Cool.
Yeah.